Okay, guys, today we're going to learn about direct variations. So building off of ratios and proportions, direct variations, we actually use those methods in order to solve it. So when we talk about a direct variation, we are talking about a relationship whereas x increases, y increases. So they go in the same, they both go up. So as x decreases, y decreases at a constant rate. So they're directly proportional. They do the exact same thing, okay? So they move in the same direction is the essence of it. Equation in the form y equals k of x, where k is not equal to 0, so k is right in front of the x. The equation shows, the equation y equals k of x shows a constant rate of change. Do y'all know what else we call rate of change? It's a word that starts with S. When we talk about lines, it is our slope. Do y'all see that? So the K is the constant of variation, and we've been calling it slope. That's the reason I'm squaring it. I always square my slope. Okay, but you'll notice it has no y-intercept. It has no plus b, so it's a 0 right there. K is always the number in front of x, just like slope. Direct variation is your output over your input, okay, for the most part. Sometimes when we write them out, we kind of write them out what we want, but it's really important to label what your top is and what your bottom is on the left and make sure it's the same on the right-hand side, okay? So on a graph, it's always going to start at the origin because it always starts at 0, okay? And they're always direct, so they're always going to be a straight line. So as one goes up, the other goes up at the same rate, okay? And they must include the origin. So your graphs are always going to be a straight line through 0, okay? Just like graphing a line. So let's do an example. If y varies directly as x and y is 10 when x is 2.4. So right now I'm going to write it down. I'm going to label it. Y is 10 when x is 2.4. Find x when y is 15. So y goes on the top on my second one, 15 over x. So when I go to cross multiply this, I'm going to do the 10 times x first because I want that x on the left. We want our letter on the left, right? And then I'm going to do the 2.4 times 15. So I get 10x equals 36. When a number and a letter are right next to each other, what are they doing? They are multiplying. How do we get rid of multiply? With divide. So your x would equal 3.6. It's going to be a pretty decimal or a fraction, okay, guys? So just make sure you notice that. Next, suppose y varies directly as x, and y equals 72 when x equals 8. So y is 72 over 8. And I just list them how I see them, how they're worded in the problem. I go from the first one, and I just state it. So find x when y is 63. So again, they gave us the y value. I'm going to put that on top over x. Now, I'm going to multiply the 72 and the x first because I want my letter on the left, and I'll multiply the other two. So I get 72x equals 504. When the 72 and the x are right next to each other, what are they doing? They are multiplying. How do I get rid of multiply? I divide. So x equals 7. Okay, these are directly what they look like on stars. So if you guys are a retester, you're taking your star algebra this year, they're going to look just like that, okay? Now, if y equals 15 when x equals 12, so there's my 15 over 12, and I'm going to be sure and label it. It doesn't matter if you put x or y on top as long as you do the same on the right-hand side. I just kind of do it the order it is in the problem. Find y when x is 32. So this one, we're actually finding a different one, right? So I'm going to do 12 times y first on this one. Oops, my arrows are backwards. I'm going to do 12 times y first because I want that letter on the left. So you get 12y equals 480. And of course, if y'all see any mistakes, always please let me know. Then 12 and y are right next to each other. They're multiplying. How to get rid of multiply? With divide. So I have y, I'm sorry, that should be y equals 40. Look at me messing up there. Copied it from somewhere else. This should be y equals 40 because we're finding when y is. We have a few word problems, and then that's it for this. Heather's weekly pay is directly proportional to the number of hours she works at the record store. Her pay is $174 for 24 hours. So I put the amount over hours. Okay, so I just listed it how it was written in here. Find the amount of pay for 40 hours. So we're looking for X over 40. We're looking for the money amount over 40 hours. I'm going to do 24 times X first because I want my letter on the left equivalent to the other two multiplied. I get this. Now, when a number and a letter are right next to each other, what are they doing? They are multiplying. How do we get rid of multiply? We divide. So X equals $290. You can use any variable there. That's fine. You could have used H for hours, M for money, well, not hours, that's not hours, sorry. M for money, you could have used whatever, and it's fine. Example 5. Eduardo counted 10 seconds between seeing lightning and hearing thunder, and he knew that the lightning was about 2 miles away. So 10 seconds over 2 miles, right? So seconds over miles. If he counted 4 seconds, so seconds is going to go on top between the next flash of lightning. So I put M for miles. Again, you guys, you can use X. That's fine. So see if you can guess what I'm going to multiply first on this one. Okay. I'm going to do the 10 times the N because I want my letter on the left, and then I'm going to do the 2 times 4. So that gives me 10M equals 8. Now, when the number and the letter are right next to each other, they are multiplying. How do we get rid of multiply? What's the opposite? We divide. So I have M equals 0.8 miles, 0.8 miles. And that is it.